Hello and welcome back for another special VMK in the game development series, only available on the DVD. So let's continue on with our previous VMK. We've incorporated the ability to dynamically change the actions that are associated with keys inside of the game. Well, there's a few keys that you'll notice they don't work exactly as expected within your game. And let me go and demonstrate some of these. We're going to go and clean them up in this VMK. So let's start our application, go into our options, go under here, and here we have our default settings. Now, let's say we wanted to go in here and, I don't know, let's just pick on one. It doesn't matter which one we pick on. I'm going to hit change, and let's say we wanted to associate this action with the F10 key. If I press F10, you notice that nothing actually registers. I'm pressing F10, but it doesn't seem to register that I'm pressing any key on the keyboard. If I press F11, you notice it seems to work fine, and as a matter of fact, the other F keys seem to work okay as well. Well, so what's wrong with F10? F10 happens to be a special key code that Microsoft has designated as being a system key code. And you'll notice that if you open up any kind of application, let me go and try this out actually. If we go inside of Visual Studio here and I hit F10, notice what happens. It actually started our program up and running. And we can stop this guy. Let's open up Internet Explorer. If we're inside here and we press F10, notice that we get a menu bar. So F10 has been associated with this special kind of action inside of Windows. Because of this, anytime we're pressing F10, we're not going into our message handler and getting our Windows message key down command. It's not going into here. If we were to go through the documentation and take a look to see exactly what's happening, what's really getting sent to us is not a Windows message key down message. Instead, what we're getting is a Windows message system key down message. So this is the guy that we're receiving inside of our game OpenGL. So because of that, we need to create a new case statement here to handle that new kind of message that we can receive. So right underneath key down, let's add in, well actually, let's do it underneath key up. We're going to add in the following. If our parameter is a virtual key code for F10, and we're inside of our game state key pressed, then we're going to handle exactly the same thing that we've done up here whenever we're pressing a key on the keyboard. We're going to call it change control, and then we're going to change our state back. So we have here change control, and then we're going to change our state back. Otherwise, what we're going to do is just set the value for P-user settings for that specific key that's being pressed to be equal to true. We need to do this because inside of our game, anytime that we're playing, we won't be inside of key press state. Instead, we'll be inside of the game state play. So we're going to be going in here and setting that specific key to be true. Because we're handling this internally, we need to return true. Otherwise, we're going to return false so that Windows handles the appropriate action that it's supposed to do if F10 is being pressed on the keyboard. Now, because we're handling the system key down command, we also need to handle a equivalent system key up command, which is going to do the same thing that we've done over here. So right underneath system key down, let's add also the following case statement. If our parameter is F10, then we're going to change our value here to be false, and then we're going to return true. Otherwise, we're going to return false and let Windows handle this F10 command. So let's save this and recompile our code and give this a try. Under options in here, let's pick on, I don't know, jump. We'll change this, we'll hit F10, and notice it now registers as an F10 being pressed. Now if we go back inside of our game, if I press the F10 key, you notice that I'm jumping up and down on the screen. So that's good, we fixed F10. Okay, what's the next key that doesn't seem to work properly? Well, let's start this up again. We'll go in here and pick on jump again, Let's hit change. This time let's hit F12. Whoa, what is this? Unhandled exception. Break, continue, or help. Well, let's break out. And it's asking, there's no source code available at this current location. Is this okay? Let's hit OK. What did we just do? Well, what we did is we automatically told our C++ compiler to break at the current location in our code. F12 happens to be a system command within Visual Studio. And within Visual Studio, anytime you press F12, no matter where your program is, it will automatically break your code and put you inside of the debugger. Because of that, we're not handling the case appropriately inside of our code. Well, we think we are, but visually it doesn't look like we are. We can just confirm that everything's running fine by hitting the arrow key here just to get it to continue running. You notice that it did register an F12 command. And if I go back into here, hit the start button, if I hit F12 again, you notice that there is another break. I hit OK, hit start, and it seems to be running fine. Well, to confirm that everything's running fine with the F12 being pressed, let's do the following. Here's our code source that we're working with, and under build, debug, here's the compiled program that we're running. So let's just run it straight from our Windows. We're not bypassing the introductory screen, so we're now going to actually see it. And we'll go into our options, into here. We'll pick on jump again. As a matter of fact, let's reset our left strafe to be the A key. So inside jump here, I hit change, I press the F12 key. You notice that it didn't break this time. As a matter of fact, I'll go into the crouch, press change, F12. Seems to be working just fine. Alright, let's see if it works just fine inside of our program. I start a new game, I go into here, press F12, you notice it's jumping just perfectly fine. So F12 is handled correctly for us. However, if you're running inside Visual Studio, it may not look like it's running correctly because you're actually invoking the debugger to start running every time you press F12. So that's just something to know about. Nothing that you need to change. It is working correctly, just the debugger is kicking in on you. All right, so let's stop that and go back inside of our code. Let's try out another key that seems to behave strangely. We'll go back in here, we'll again pick on the jump, click change. Let's see what happens when we press the Alt key. Again, I'm pressing the Alt key, but nothing is registering. If I press any other key on the keyboard, it seems to register just fine. So there's something wrong with the Alt. And again, the Alt is very similar to the F10. You'll notice if I go inside of our Internet Explorer here, and I hit the Alt key, it also brings up a menu. Alt happens to be associated with a system command. So we also need to handle the Alt key in a similar fashion that we handle the F10 key up here inside of the system key up as well as the system key down. We're going to add the following code to system key down. If the W-param is equal to virtual key code menu, menu is the same thing as pressing the Alt key, then if we are inside of the key press state, we're going to change the control to W-param, and we're going to change our state to go back to our previous game state. Otherwise, we're just going to take this value here and set it equal to true, and we're going to return true. Down here inside of the key up, we're adding another if statement. If our parameter is equal to virtual key code menu, then we're just going to take the parameter and set it equal to false. We're going to return true, and then we're done. So let's go and compile this code and give it a run. Under options, in here, picking on the jump, hit change. I'm going to hit the left Alt key. You notice it brings up L Alt. Seems to work fine. Let's just go into our game quickly, and I'll hit the left Alt key, and I seem to be jumping up and down. Great. Seems to be working fine. If I go into the options, and I'm going to pick on jump again, hit the change button. This time I'm going to hit the right Alt button. Notice that it still registers as a left Alt. So there doesn't seem to be a way for me to differentiate between the left Alt and the right Alt. They seem to be giving me the same key code. And if you look inside of the Windows message handling code, you'll notice that, yes, that is true. You are getting virtual key code menu for both Alt keys. However, there is a way to differentiate between the left and the right. And to differentiate between them, you need to not only look at wparam, you also need to look at lparam. So to understand what's going on here, let's open up Visual Studio. And if we go into the Windows message key down message that gets sent to us and read through here, you'll notice that wparam is a specific virtual key code. However, if we go down here and take a look at lparam, bit number 24 specifies whether the key is an extended key, such as the right-handed Alt or the right-handed Control keys. If that's true, then this bit, number 24, will have a value of 1 if it's extended and 0 otherwise, which means it's going to be 0 if it's the left button and it's going to be 1 if it's the right button. So we need to take a look at this lparam value for bit number 24 and figure out whether it's 1 or 0. And that way we'll know whether it's the left one or the right one that's being pressed. Let's go into our code and implement this now. We'll start off with the system key down. We're going to go down here inside of wparam is equal to virtual key code menu. And if we are inside of the menu, then we just need to add the following if statement. If lparam single ampersand sign, and we're checking the hex value of 1, and then we have 0, 0, 0, 0, 0, 0. So we have 6 zeros there, and then a 1. This is bit number 24. If you're not familiar with bits, hex values, decimals, things like that, I'd recommend you go to my website, take a look at the introductory C++ videos, and I think the very first VMK there, I talk about number systems. And I describe the differences between hex numbers, decimal numbers, and binary numbers. And there I think I wrote some code to demonstrate how to work with bits. So that's what I'm doing here is I'm checking to see bit number 24 and trying to figure out whether it's high or low. In other words, 0 or 1. If it is 1, then I know it's going to be the right the right Alt key that's being pressed. So I'm just going to overwrite wparam and make it equal to the virtual key code for the right menu. Everything else will stay the same because if we're inside of the key press, now wparam here is going to be the right menu rather than the left menu, and so on. We're going to need to take the same code and implement it down here inside of the system key up. So again, we're checking to see the 24th bit. If it's true, we're going to set the virtual key code to be the right menu or the right Alt key, and then we're going to handle it appropriately. So let's save this and compile and give it a run. Under here for the jump, we're going to change this to the right Alt key. So now it says R Alt, and crouch, I'm going to change this to be the left Alt. So we have R Alt and L Alt. Going back inside of our game, if I press the right Alt key, we're jumping. If I press the left Alt key, I'm crouching. So there we go. We fixed the differentiation between the left Alt key and the right Alt key. Let's quit back into the options now. And let's take a look at the next key that seems to behave differently. Let's pick on the jump action as well. And this time let's pick on the control key. If I press the left control key, you see we have L control. And if I hit the right control key, you notice that I have L control as well. So again, we have a similar problem. I can't seem to differentiate between the left and the right control keys. But once again, if I quit out of the application and go inside of MSDN here, the control key is handled under Windows Message Key Down. If I read the description here, again, it'll say bit number 24 tells me whether the right hand or the left hand control key is being pressed. Same sort of thing that we did with the Alt key, which means we can take this code here and duplicate it inside of our Windows Message Key Down command. Well, actually, the code is going to be a little bit different than what we had earlier. Right at the very top here, before this whole escape check, I'm going to add the following code. If wparam is equal to virtual key code for control, We know we're going to be pressing a control key, and if lparam for the 24th bit is high, then we know that instead of the left control key, we're pressing the right control key. So we're going to change wparam to be equal to the virtual key code for the right control key. So that's going to handle the one case, and everything's going to filter through here and it gets set accordingly. For the key up, we need to do a similar kind of thing. We're going to check to see if our virtual key code is control, and if bit number 24 is high, and if it is, we're going to change wparam to be virtual key code right control, and everything else will follow through. So now we can go compile our code and give this a run. Back inside here under jump, if I press the left control key, we get left control. Under crouch, I'm going to choose the right control key, and we get right control now. And if we go and test this out inside of the game, left is doing a jump and right is doing a crouch. So there we go. We fixed the left and the right control key differentiation. Let's take a look at the next key on the keyboard that doesn't seem to behave properly. Again, I'll pick on the jump. I'll hit the change. I'll press the enter key. If I press the enter key, I get enter showing up here. That seems fine. If I go and hit change and press the enter key on the number pad, you notice it's also showing enter. Well, if I go here and press enter on the number pad, you'll notice that this enter and the enter on the main keyboard is the same enter. And as a matter of fact, this problem is the same thing as the left and right alt key, or as well as the left and right control key. We need to take a look at this extended bit to tell us whether it's the regular enter key or whether it's the extended enter key, which is the one on the number pad. So again, we can quickly fix this just by going into here and checking the bit number 24 for our enter key. So in here, we're just going to write else if wparam is the virtual key code for return, which is equivalent to pressing the enter key, and the 24th bit is high, then we're going to change the key code to be virtual key code separator. And separator happens to be the enter key on the number pad. So we're going to take this code and also implement it up here inside of the Windows message key down. Let's build this and give it a try. Options. For jump, we're going to make this the regular enter key. For crouch, we're going to make this the number pad enter key. So now you can see it's displaying number enter. And if we go and test this out, I'll just run over here to the corner to make it a little more obvious. Regular enter key, I'm jumping up and down. Number pad enter key, I'm crouching down. So that seems to be fixed now. One thing I wanted to show you here, in case you are wondering where I'm getting these key codes from, if you go under declaration, you'll notice that it'll open up winuser.h. And inside here, this is where the key codes are being defined for all the different actions that we're using. We have shift, control, menu, which is the alt key. If we scroll down a little further, you'll notice that there are some extra codes. Where are they? Here. For the left shift, the left control, left menu, right menu. You'll notice I'm not using the left control or left menu. Instead, I'm using the general virtual key code for control and virtual key code for menu. I'm just assuming that those are the left ones by default. And if they're not the left ones, then I'm using the right ones. So there's different ways to handle this. If you read this comment here, it actually says that the only way you can get these left and right values is by using these function calls here. But we're not using them. We're instead using the Windows Message API messages directly to differentiate between these. Okay, let's go back into our code and take a look at the next key. The next one that we're going to take a look at are the shift keys. If we go into here and hit the jump again, if I'm pressing the left shift key, you notice it says shift. And if I change this and I press the right shift key, it says shift as well. Right now, there's no way to differentiate between left and right shift. If we take a look at, where was that function? It's inside of user settings, get control key text. I think it's this guy here. Nope. Get key text. This is the one I want. Anytime that we're displaying inside of the list there which buttons are pressed, here's the text that we're showing on the screen. And if we scroll through here, you'll notice that I've commented one out, and the one that I've commented out happens to be the shift one. Well, let's uncomment him and play around with him for a little bit. So by default, he's just going to show shift rather than left shift, and we're going to try to make the right shift work. However, you'll notice that right shift, it doesn't work properly. Let's take a look at this. The virtual key code for the shift key works slightly different than the alt key or the control key. And because of that, we can't use bit number 24. Now, I only know this because I was experimenting around inside of the code here to figure out, well, what is happening when I'm pressing the left key or the right key for the shift. Let me demonstrate what I mean. I'm going to put a breakpoint here for the virtual key down, and I'm going to run my program. It's just going to compile because I've changed that code for the right key message. But anyway, let's go in here. I'll select on jump, hit change. I'm going to press the left shift key. Inside here, we've broken our execution after we've received the key down command. If we take a look at the W param, we notice it's currently 16, and L param is this weird number here. If I right click and select hexadecimal display, we see that we get some value here, 002A0001. The 24th bit is 1, 2, 3, 4, 5, 6 zeros and 1. So it should be 0, 1, 0, 0, 0, 0 all the way through if I'm pressing the right shift key. So if I'm pressing the left shift key, I'm getting a 0 here and then 2A and then a 1. Okay, fair enough. Let's run our code. So it registered a regular shift. Now I'm going to change and hit the right shift key. Well, look what happens here. L param is not 0, 1, 0, 0 all the way through. Instead, it's 36 here rather than 2A. So I thought to myself, okay, this bit here isn't getting registered. Instead, something else is changing here between 2A and 36. Well, if we look at the documentation, it says here that bits 16 to 23 is the specific scan code for the value that is getting changed, which is basically the virtual key code that we're interested in. Well, okay, so there seems to be two different codes, 36 and 2A, to differentiate between the left shift and the right shift. So I thought to myself, okay, well, let's write some code that will tell me if I'm getting 36, which is the right shift key, and then use that whenever we want to handle the right shift key. So let me show you how that code was written. Another else if statement, we're checking to see if we're using the virtual key code for shift. And if that's the case, I check to see if the L param value here is 36. And if it is, then I have to check to make sure that both 36 is true. So I equate it here. It's a little bit different than up above because I'm not just checking one bit. Instead, I'm checking to make sure that 36 is the value that I have inside L param here. If that's the case, I'm going to change my virtual key code to be the right shift key. I can then do the same thing inside of key up, which is down here. So now I should be able to differentiate between the left and the right shift key. And sure enough, I can. However, there's a problem with this. Let me demonstrate it by the following. I'm going to choose left strafe here, make this the left shift key, and we'll remove this breakpoint. Just continue on through. So we get shift here, and the right strafe, I'm going to make this the right shift key. So you see it registers as right shift. Everything seems to be fine. However, when we go in and run our code, and I press the left key, it moves to the left. If I press the right key, it moves to the right. Seems to be working fine. However, notice what happens if I press both keys at the same time. I'm going to press the left button first, so I'm moving left, and then I'm going to press and hold the right mouse button, the right shift key. So I stop moving because essentially I'm moving in the left and in the right direction at the same time, which means I'm not moving left or right, I'm just sort of stationary. So that's correct. However, when I release both keys, I'm now drifting off in the left direction. And the only way I can stop is if I press the left shift key. Let's try that again. I'm going to press the left shift key, hold it down, and then hold down the right shift key. Now I'm going to let go of the left shift key and then let go of the right shift key. Again, I'm drifting towards the left. So there seems to be some sort of discrepancy between these key codes and the values are not getting reset properly. If I go inside of the options and try to reproduce the same sort of thing with the left control and the right control, you'll notice that I don't get this problem. I'm going to hit the left control and the right control. I'm now holding both left and right at the same time, so I'm not moving in any direction. And when I release both, I don't go anywhere. It's perfectly fine. It seems to work fine. Left and right shift don't the Windows messages for left and right shift do not get handled properly so that I don't get resetting the left and right shift keys properly. Because of that, I wouldn't recommend using this code at all. It's not stable and it doesn't behave properly. So that's why I went into the user settings here and I commented this out because it's currently untested for use if you're going to be using both the left shift and the right shift at the same time. If you know you're never going to be using both the left and right shift at the same time, then go ahead and use this code. Otherwise, I wouldn't recommend it. So I'm just going to comment this out. I'm going to leave it in my code, but I'm just going to comment it out so that it doesn't actually function. And back in here for the right shift. Okay, so I don't know how to handle the left and right shift keys properly. What you can do is try to use these function calls here internally within your code, but I just said, forget it. I don't need this functionality for the specific games I'm going to be making, so I'm just going to leave it as it is. The shift key, whether it's left or right, is going to be one action. You can't differentiate between them. A lot of talking. There's only a few other things I wanted to show you how to do with these custom key codes. As you've seen already, there's, oh, sorry, I didn't want to go in there. Inside of here, if you take a look at the key codes, you'll notice that the very first few are for the left mouse button, right mouse button, and middle mouse button. And you'll notice that inside of the code that we wrote over here, I actually have text to output if you do press the left mouse button, right mouse button, or middle mouse button. But you'll notice that if we run the code, go under options, and for instance specify jump, hit change, I press the mouse buttons, it doesn't register as something is being pressed. Well, we need to go ahead and implement the functionality so that when we press the mouse button, we can associate it with these actions. That's pretty simple to do because we've already have the mechanisms built into our code to handle this. Let's first handle the left mouse button being pressed down. We've already handled that already down here. Whenever we get a left mouse button pressed down, we get this Windows message being called to us. Well, all we need to do is go into here and add the following code. We check to make sure that the game state is key press. If it is, then we're going to change the current control to be virtual key code L button. This is the left mouse button control key. We're going to return back to the previous screen and then we're going to return true. Otherwise, we're just going to set the virtual key code for the left mouse button to be true anytime we get this message. Similar to the key up and key down, we also need to handle the left button up so that we can reset this value here. Everything else down here we're going to leave the same. So under left button up, we're going to add the following line of code. We're taking puser settings, m_b keys for the virtual key code left button, and we're setting it to false. Everything down here we're going to leave the same. Now we've added the functionality to be able to use the left mouse button as if it's a regular button being pressed on the keyboard. So let's pick on jump. I'm going to hit change. I'm going to press the left mouse button, and now you see it says left mouse. We can go into our game, and anytime I press the left mouse button, I'm now jumping on the screen. So there we go. We've added the functionality for jumping using the mouse. We can do the same thing for the middle mouse button as well as the right mouse button just by handling the appropriate messages. So underneath here, let's add those in right now. For the right button down message, again, we're checking the code. If it's the key press code for the game state, then we're going to select change control for the virtual key code right button. We're going to change the state back to our previous screen, and otherwise, we're going to go in here and set this guy to be true for virtual key code R button. If R button is pressing up or being released, then we're going to just change this guy to be false. For the middle mouse button, which is usually the button located underneath the scroll wheel if you have a scroll wheel. If you only have a 2-button mouse, then you won't have a middle mouse button, and then this won't actually function. But you can type it in here anyway in case your game players do have a 3-button mouse that will be playing a game. Again, we do the exact same thing. We check to see if the game state is key press. If it is, we're going to change the control to be M button, change back to the previous state, and then we return true. Otherwise, we're going to set this value to be true here for M button. And then on key up for the middle mouse button, we're going to set the same key code to be false. Now we can quickly just compile this and give it a try. Make sure that everything's working fine. We're going to go in here, I don't know, let's make the flashlight the middle mouse button, so we get M mouse. And crouching, let's make that the right mouse button, so we get R mouse. And if we go into our game, we had middle mouse button is our flashlight. I don't know if you can see that or not. Ground should be green. If I press the flashlight, it turns black. Okay. And the right mouse button was crouching, so I have to press and hold it to perform a crouching action. Let's just move towards the corner here so we can see that a little bit more on the screen. So there we go. We have full control using the mouse now. Left mouse button, right mouse button, middle mouse button, or by customizing the control keys for the keyboard to the specific actions you have within your game. So play around with this, add your own actions inside your game, and map them to whatever keys you like. Remember, the only ones that don't work properly are the shift keys because we can't differentiate between left and right shift. Oh, there's one other key that I didn't talk about, and that's the print screen key. You'll notice that if we go into here and let's pick on jump again, hit change, and I press the print screen button, it doesn't do anything. It's very similar to the other keys that had problems. If I press K, it seems to work just fine. Print screen, for some reason, does not send a Windows message key down press. Where are we here? Windows message key down, right here. We don't get one of these when we press the print screen button on the keyboard. Instead, we get a Windows message key up when it's released. I don't know why Windows does it this way, but that's the only way you can handle a key press of the print screen, is by monitoring the key up. So I wouldn't recommend letting the user use the print screen to have an in-game action. You can still do special kinds of features like maybe, I don't know, capturing the screen or something like that upon a key up command whenever it's the virtual key code for print screen. And as a matter of fact, I think I wrote a command in here for getting the print screen. That's just, it's the snapshot here. So if you're getting virtual key code snapshot on the key up Windows message, then the print screen was pressed and it's being released. So you can handle it in here, but you cannot handle it inside of here, which means that you will not be able to register it as a specific key that you can associate with an action. So just something to be aware of. And I think that's it for the special keys. I hope this video was informative, and come back for the next one where I'm going to show you how to modify the first-person shooter game engine and make it a third-person game engine.